there are a few ways to handle this question, but regardless, you're going to need to know what it means when there are infinitely many solutions. And we saw this earlier in this module. So this is not like something that you have a fluke chance of getting. Like this infinitely many solutions thing could easily come up on every test, maybe multiple times. Basically, just to recap, infinitely many solutions means that we have two equations that are exactly the same. So obviously, looking at the answer choices, these are not the same equation, but the way that they can be the same without looking the same is because one is kind of a multiple of the other. So well, I'll show you that method at the end, the multiplication aspect, because it's not obvious just looking at them how that's going to work. But we have Desmos here. And if I graph this original line, right, 15x plus 25y equals 65, we just get this line. And if it's supposed to be infinitely many solutions, what it means is that if I graph another answer choice, the right answer is going to just go right over this line. It's going to be the same. So let's do it. Let's just go through. Let's do 12x, this is choice A, plus 20y equals 52. Well, obviously that's not the same. Goes in the completely different direction, right? So that's not right. Get rid of that. We can try choice B really easily because all we have to do is add a negative. So let's go to that and just make it negative 52. Well, it moved it, but it's still going in the wrong direction, so that's no good. We can try choice C. Let's get rid of the negative. And now we put the negative in front of the 12. And look, where'd it go? Well, look, it's green now where it was blue, right? So let me turn the green off, green on. It's just overlapping the blue. So hopefully you're not colorblind and you can see that difference. But there you go. That's probably it. Let's just try choice D to make sure. That's the same thing, negative 12x, but now it's minus 52. And sure enough, it's in a completely different place. So even if you have trouble seeing that the two lines are overlapping, hopefully you can see when they're not overlapping. And that would leave us with choice C, which is the answer. So again, that's what it looks like, right? On, off, right? You can see it's just overlapping. That's infinitely many solutions, so the same line. But like I said, they look different. So what's going on? How is it possible they're the same if they have different equations? Well, basically, there's like a kind of like a baseline equation that both of these kind of are born from. So in order to find it, we better take the original, negative 15x plus 25y equals 65, and try to simplify it the same way we think about a fraction, right? If we have a number on the top and on the bottom that are both have the same factor or divisible by the same thing, we pull that out and then we are left with the same value, but the fraction is kind of smaller in number. Like the pieces that make it up are smaller because we've reduced the fraction. So we kind of want to reduce this equation to something simpler, and we can do that by dividing every single piece by 5. And when we do, we're going to get negative 3x plus 5y is equal to 13. That's our baseline. And now we're saying, okay, well, what could we do to that to make it look like some of these others? Well, I see the 12 and I'm like, okay, well, 3 times 12 is 4. So what if we did that? What if we multiplied by 4? We'd have to do it to all the pieces. And if we did, we'd get negative 12x plus 20y, and 13 times 4 is 52, which is exactly what we got in choice C. So there's my proof. It's unusual to me, having done a lot of these questions in the SAT, that we have equations where it's not like obvious what the relationship is, right? The multiples. So we had to kind of reduce one and then make it bigger again in just a different way, but it's not that like intensely mathematical. It's also, maybe you would have picked C simply because of the placement of the negatives, okay? I advise against that though, because they could have easily made this question a little bit harder by changing the negatives, right? So let me just show you. This is not an answer, but if we took our negative 3x plus 5y equals 13, and instead of multiplying by 4, we multiplied by negative 4, that's going to change it to positive 12x minus 20y equals negative 52. So compare it, right? Compare also all the way back to the original right here. It's still the same overall proportions, but notice the negatives have moved. They're on different numbers. And so that would be harder for our brain to just see and kind of account for. So I don't recommend just kind of feeling these kinds of questions out. Prove it. Prove it using Desmos. Prove it using algebra. whatever way works for you, I think it's just a matter of being certain, because this is a case where the SAT could easily have inserted this extra little trap. I know that they've done it in the past, so we want to be aware that that's how they think about the hardest questions, and we need to just be one step ahead, preparing just in case they do that.